In part 2, right, the only difference here is that instead of increasing, it's decreasing. Instead of increasing, it's decreasing. So in this case, our rate of change, our slope is negative here. Negative what? It's negative 200. Okay, negative 200. So it's going to be negative 200 times x plus 8,400. Again, the slope in this case, it's changing by a fixed amount. Since it's decreasing, it has to be negative. And again, the initial value is 8,400. So that's good. Okay. Are there any questions on 1 and 2 before I keep going? Okay, let me keep going then. So for 3, notice it's increasing by a percent, right, each year. What does that tell you? Exponential growth. So it's increasing by a percentage, right? So it's exponential growth. So it's increasing by 6.5%. What does that tell you? That tells you the R is 0.065. Number 3, that's how I get R over here. And the initial value, again, is 8,400. So this is our function. This is our wonderful function. Okay. That's for 3. For 4, it's similar, except except 2 things, actually. It's decreasing by 8.1% every 2 years. So again, we have exponential decay. Right? So in this case, R is going to be 0.081, but we have to subtract though, minus, because it's decreasing. Notice also it's not every year, right? It's every 2 years. So going back to this, in that case, it's every 2 years. M is 2. M is 2. So in this case, our exponent will be x over 2. X divided by 2, as you can see. And then finally, every 6 months at 9% increasing, the value increases by 9% every 6 months, right? So it's, okay, so R would be 0.09, 9% to a decimal. Down here, it's increasing, that's addition. Every 6 months, that's twice a year, right? 2 times a year, there are 12 months in a year, 2 times x. Right? Twice, every 6 months, that's 2 times per year. Capital N is 2, which is good. Good. All right. Are there any questions on these? I mean, normally I would move on to chapter 5. I mean, I didn't think I would have, I don't expect to have to start it today, but we'll see. What I want to do now, though, is I want to do a few word problems. I figured those are good examples. Okay. So here, if you look at this one, this actually came from the book. That's why I have this here. So we have this function, right? The function, let's read it actually. The function v of x is 2.5 times x plus 25.4. This gives us the value in thousands of dollars of an investment made after X months. Okay, well, let's interpret the rate of change in this situation. We're going to interpret that. Remember, rate of change is slope, right? And notice also, this is in the form of mx plus b. So it's in the form of mx plus b. Well, that tells you it's linear. And the coefficient of x here is our slope, our rate of change. Okay, so what is the rate of change here? 2.5. 2.5. Okay, now remember, what does the rate of change actually tell us? Well, that's what this line here does. For each increase, for each unit increase in input, the rate tells us how much the output will change. All right, in other words, if you were to increase x here by 1, the function here is going to increase by 2.5. So again, that's what the rate of change tells us, right? You increase x, your input, by 1 unit, then the function will change. It'll increase or decrease by whatever the slope is. So if we went from x to 1, v of x will increase by 2.5. And let's also consider the units. And again, I think I've done this before, but I feel better doing it again. The units for output divided by the units for input. That's what the rate of change is. I mean, really, if you remember, it's slope. And slope is change in output over change in input. That's one way to remember this. Although I guess it'd be a little bit easier because my exams are take-home in this class. So the units here, well, the output, we are told, is thousands of dollars, okay? The input here is months. That's our input, right? So the units for our rate of change is thousands of dollars per month. Maybe this should be singular, but I guess it's okay. But altogether, the investment is the interpretation of the rate of change. The rate of change tells us that this investment is increasing by 2.5 thousands of dollars per month. Let me just fix that. Let me just make that, get rid of this S. I mean, if you happen to write S like months instead of just month, I'm not gonna, mark it wrong. I think it sounds better if it's just one, if it's singular. So again, altogether, the investment is increasing by 2.5 thousands of dollars per month. Okay, so we have that. Are there what questions do you have about this? Okay, let's keep going then. So that's one word problem. There are similar ones in the textbook. So I think they all have their answers in the back, although I don't think they give an explanation as much as this. But you can always ask me for that in office hours. You're more than welcome to do that. Just fix this. Just driving me crazy. There we go. All right, now I feel better. Okay, just had to fix that error. So, all right, next. So here's another word problem, which is also in the book. So a new charter school opened. When a new charter school opened in 1996, there were 440 students enrolled. That's given, okay? We're going to write a formula for N of T. That representing the number of students attending the school, enrolled in the school, in other words, T years after 1996. Assuming the student population does these things. So we're basically going to write N of T for each situation here. And again, when they say attending this school, it's the same thing as enrollment. If you're enrolled, you're attending the school. And notice also that the units T, I mean, if you use X, that's fine, but T here is the number of years since 1996. So times 0 is 1996. Okay. And in other words, what does that tell us? Well, 440 students were enrolled, in other words. That's what's happening here.